Okay, so for the next question, right, it's kind of a kinetics question plus friction question. So yeah, let's go ahead and start it. So a box is pulled up, right, with a string, and then suddenly the string is cut, but it's moving at some speed of 2 meters per second, and then after a while it comes to a stop of 1 meter after traveling the distance of 1 meter, right? So this can be thought of as some initial velocity u, right, and then after that it reaches a final velocity of v equals to 0. And so we can ask the question of what acceleration, right? What was the acceleration experienced by this box? Yeah. So in order to apply v squared is equal to u squared plus 2as, must ask the question of whether acceleration is constant. And in this case, acceleration is constant, right? Because um, friction is friction is maxed out, right? In this case, friction is maxed out because as long as the object is sliding, right, friction is always maxed out at mu n. So yeah, so because friction is maxed out, friction is constant, and gravitational acceleration in the parallel component, right, is also constant. So in this case, we can use v squared equals u squared plus 2as because acceleration is constant, right? So we have v squared equals u squared plus 2as. So that will just give us, so taking this parallel upward slope as a positive, or as in the increasing direction, right? Positive slash increasing. So upward positive, upward increasing, I mean, taking that as a definition for increasing direction, right? We see that 0 equals to u squared is 2 squared plus 2. A is something we do not know, right? S, what's the distance that travel? Is travel 1 meter, right? So if we rearrange this, we get that A is equals to minus 2. And that makes sense because that means that acceleration of the box, right, when it's traveling, right, is that acceleration of the box is 2 in the downward direction, right? Because we defined upward as increasing. So so acceleration vector being negative just means that acceleration vector is magnitude of 2 and is pointing downwards. So the acceleration is 2 meters per second squared. All right. So yeah, okay, so now we know the acceleration, we can turn to the friction aspect. So what are the forces acting on the box when it's moving up? Right? When it's moving up, there's gravitational, so there's mg, and there's also normal contact force, n, and there's also friction. Which direction is friction, right? Friction, because the box is traveling upwards, right? The box is traveling upwards with some velocity, right? Even though it's accelerating downwards, right? Remember, friction cares about the sliding motion, and in this case, the box is sliding upwards, right? So friction will oppose that, right, and try to stop it, right? So friction will be pointing downwards. So friction will be pointing in this direction. And another question is, what is the value of friction, right? In this case, because the object is sliding already, right, friction is equals to mu n because it's maximized, right? If we had a scenario where the object is in static equilibrium, is not moving, right? There's no sliding, then of course friction will adjust its value to prevent any sliding from happening. But in this case, we're in a scenario where the object is already moving, right? It's already sliding up. So friction is already failed at its job. So the very least it can do is try its best. And in this case, trying its best means that is being maximized as mu n. Okay? So so you can see that if we sum up these three vectors, we're gonna get a vector that is, we're gonna get a net force, right, that is in the downward direction. We're gonna get a net force that is in the downward direction, and we're gonna find what this net force is, right? So as with the previous question, right, we can deduce that n is equals to mg cosine theta, because if we break down this mg into two components, right, one is which is perpendicular and one which is parallel, right, we can see that this mg cosine theta, this mg sine theta, right, where theta is the angle here, angle tracing gives us here, and that gives us that. So n must be mg cosine theta to prevent the box from sinking into the ground, right? Note that even though it's traveling, right, even though it's moving up the slope, it is not moving perpendicular to the slope, right? It's moving parallel to the slope only, right? It's moving upwards, but in the perpendicular direction, there's no velocity, there's no acceleration, right? So hence, n must be equals to mg cosine theta to prevent sinking. Then friction, we know is maximized as mu n, right? Because the object is sliding already. So friction in this case is equals to mu n, which is mu mg cosine theta, right? And so if we sum up all the forces, right, the net force in the parallel direction is equals to the F net in the parallel direction is equals to number one, there's gravity, right? There's gravitational. There's gravity in the parallel direction, right? You know the normal contact force is perpendicular, purely perpendicular. So there's no contribution of the normal contact force to the parallel component of the net force, right? And the other one we see is the mu mg cosine theta, which comes from the frictional force, which is parallel to the slope. So net force is in the parallel direction is mg sine theta plus mu mg cosine theta, right? Yeah, so this equals to F equals MA, right? M is capital M. So what we get is that A is equals to G sine theta plus mu cosine theta, right? I factorize out G. And yeah, so in this case, what is theta? Theta is 1 radians, right? Theta equals to 1 radians. And we know that acceleration, right, which we got previously, acceleration is -2, right? Or rather, acceleration has a magnitude of 2 in a downward direction, right, parallel to the slope. So this is 2. G is 9.81, right? And this is sine 0.1 radian plus mu cosine 0.1 radian, right? And we plug into the calculator, what do we get, right? We get that 2 over 9.81, and then we get the 2 over 9.81 minus sine 0.1 over cosine 0.1. This is the value of mu. Okay, so plugging this into a calculator, and don't forget to set your calculator into radians mode. If not, you're going to get a wrong answer. So I'm punching my calculator, and I basically get mu is equals to 0.10456, which is to 5 dp, right, to 5 sf, which is approximately 0.1. So the answer is B. Okay, so that's how you do this question.